Hello everyone, it's Zhuzhen here. I'm the TI of this class. Today I'm going to give a tutorial. The topic is thermodynamics in everyday life. First, let's see the definition of thermodynamics. Thermodynamics is a branch of physics that deals with heat, work, temperature, and their relations to energy entropy, and the physical properties of matter and radiation. The behavior of those quantities is governed by the four laws of thermodynamics, and this identification is identified by Wiki. And here, let's see the four laws of thermodynamics. Some of you might have learned these things before, but I think if you want to study this systematically, you might come to learn physical chemistry at your higher grade. So let's see it. The zeroth laws of thermodynamics defines thermal equilibrium thermal and forms the basis for the definition of temperature. If two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. And for this one, it's kind of like a math question, and that they perhaps didn't have some clear examples in everyday life. So let's see the first laws of thermodynamics. It states that when energy passes into or out of the system as work, heat, or matter, the system's internal energy changes in accordance with the law of conservation of energy. How to understand this? Because and it as we know, the energy didn't appear or disappear, and it must transform from one kind to another kind, and during the process, the total amount of energy didn't change at all. So this this rule states that the maintenance of energy in a certain system. And let's see the second law of thermodynamics. It states that in a natural thermodynamics process, the sum of the entropies of the interacting thermodynamic systems never decreases. A common corollary of the statement is that heat doesn't spontaneously pass from a cold body to a warm body. And this one is interesting, and I don't and to and to and to you if you want to know this real, you must learn the concepts of entropy. And after you know that, you will, and if you want to understand this more quickly, I think you can remember the you can try to remember the sentence this a common corollary of the statement, because if after you have learned the physical chemistry, you can have a better understanding of this. Let's see the third laws of thermodynamics. It states that a system's entropy approaches a constant value as the temperature approaches absolute zero, with the exception of non-crystalline solids, and that is almost gases. The entropy of a system is at absolute zero is typically close to zero. And for the third laws of thermodynamics and the zero laws of thermodynamics, they are kind of theoretical. But today's topic is the thermodynamics in everyday life. So I will give some examples of first law of thermodynamics and the second law of thermodynamics. The first part is the applications of first law of thermodynamics. And the first one is the power generation. As we know, the three types of fossil fuels are coal, crude oil, and natural gas, and they oh and the- and by and they can act as a main resource of energy during about after the industrial revolution. And but there is question for these for fossil fuels because they are not because they are not green. You can see the film from the climate, and it and the the chemical waste from from the the from this gradual pollute the environment severely, and the amount of these fuels stored in our earth is become more and more less. To substitute this kind of energy, that there are many new powers. For example, the solar power. We can see the solar panels in this picture. By this solar and by it can absorb and transform solar energy to other kind of energy like electricity. And for this one, we can take use of water power to generate energy. For the most famous one is Sanxia in Hubei province. That's a very big water power station. And this one is wind power. We can see the fans in this picture. And in some countries like Dutch, the wind power can serve as a main power resource. And here is the nuclear power. And there are many nuclear powers in China, nuclear power is a very robust power resource. But the question is, it might cause some danger. It might threaten the health of people. For example, the leak of nuclear might damage an area. And nowadays, every country try to limit the CO2 emission because the because it because the emission of CO2 will increase the temperatures in our Earth. So it's a very severe question to be solved. And to solve this question, Chinese scientists develop a new concept. It's called liquid sunshine. And this is and it and it they want to transform the typical fossil source to green alcohol. And this green alcohol can be like a liquid sunshine. And this is the formation of liquid sunshine. It's a methanol. It can be got from CO2 and hydrogen, and by electricity catalysis. The methanol can be synthesized in ton scales, and for the methanol, it can and generate CO2 for pure CO2 applications, and hydrogen gas for uh for for other fuel cell. And by using clean electricity and clean liquids, we can get energy in a more clean way, in a greener way, and solve many questions about the resources. And here is the second example, the food digestion. As we can see our digestive system here, and many and it helps us to abstract the energy from food, and we can see like the carbohydrates, fats, and others, they can transform to ATP and and generate some heat to keep us warm. some chemical waste like carbon dioxide, water can be eliminated from our body. And here is another example, the photosynthesis. And here is the typical formation of photosynthesis. From CO2 and water, it can transform to glucose and oxygen. The glucose can be used as the energy source, and the oxygen can be used for the for our to breathe. And here is the solid the structure of a cell, and in the chloroplast, the water, sunlight, and carbon dioxide can get into the Calvin cycle. And ATP can form during this process, and oxygen and glucose can released during the process. Then let's see some examples of second laws of thermodynamics. Before that, let's see the identifications again. It states that in a natural thermodynamics process, the sum of the entropies of the interacting thermodynamic systems never decreases. For example, you can see the ice here. It has a low entropy, but when we put this for some time, it can melt to water, and for this one, it has a much higher entropy. And if we put some gas in a box, the entropy is low because they are highly ordered. But when we open the box, the entropy is increased, and this system become more disordered. And there are some other examples there are other examples of the application of second laws of thermodynamics. For example, when we put coffee at this place, the temperature gradually become lower, and because we can see the sentence here, the heat doesn't spontaneously pass from a cold body to a warm body, so the heat of the coffee can gradually release to the air, but because the coffee has a much higher temperature, and the air has a lower temperature, so. And here is another example. We can see the cocktails here. Very beautiful and a lot of colors. It is come from many ingredients, and when we put the two ingredients together, they will mix with each other spontaneously, and once after they mix with each other, it's impossible for us to separate them again. So it's also the process of the spontaneous increase of entropy, and the second laws of thermodynamics also have a lot of roles in the engineering, and it states the. And if you want to have a better understanding of this, you might try to learn some knowledge, get some knowledge of physical chemistry. And here is my sharing. Thanks for your listening.